Just to say a brief about QuantumBlack. So basically, first of all, let me just introduce myself. I am Rupam Das, so I'm the head of QA engineering here in QuantumBlack. I have around 20 years of experience in software testing and quality assurance. Have worked extensively with financial services, government, and the pharma industry. So my hobbies include traveling, watching movies, and also cooking. Going forward, with regards to our company, who we are. So QuantumBlack, we had our humble beginnings way back in 2009 when we started, and recently we celebrated 10 years of our existence. We are acquired by McKinsey way back in 2015, and since then we have been helping McKinsey clients and working together with them in trying to get their projects up and running. The first and foremost project which we did as QuantumBlack was with Formula One. So what we did was we tried to gather insights out of the data which they had given and also help them solve some critical problems. Then on, we have been serving clients across different domains, across financial services, healthcare, natural resources, telecoms, and so on and so forth. Yay. So this is the best part. We are hiring. So in case you're looking for any sort of new opportunities, whether that might be QA or data science or data engineering, please feel free to visit our careers page, and please feel free to apply directly on the site. Thank you. But last but not the least, I would like to invite Nasef to just talk about the evolution of testing. Up to you, Nasef.
Sure. Thank you, Rupam. Hello, everybody. Thank you for coming here today. So today I'm firstly, let me describe myself. So I'm Nasef Khan. I've 7+ years of experience in software testing and development in higher education, fintech, and also cybersecurity. So in my current role at QB, I help build tools and libraries that are used by our data engineers and scientists in the field. And my passions include kind of all things tech, reading, sci-fi, traveling, and gym. So to move on to the subject of this talk, so I'm going to be talking about the evolution of QA. And yes, I'll be taking you guys through a journey through the history of QA. So hopefully we'll look at some common practices and trends, and then we'll use these insights to see what the future holds for this exciting and dynamic field. So what is quality? So ISO 8402 defines quality as the totality of features and characteristics of products or services that bear on its ability to satisfy stated or implied needs. ISO 9000 kind of builds on this and defines quality assurance as part of quality management, focused on providing confidence that quality requirements will be fulfilled. Let's start on the history of QA. So where did QA or quality assurance start? So historians think it really began with the guilds in the Middle Ages. So with the growth of cities and kind of towns and complex economic networks, you had association of craftsmen or merchants forming mutual aid and protection for the furtherance of their professional interests. And the way this worked is, if you want to be part of a guild, you have to basically be inspected by guild masters, and your goods would be regularly kind of checked for quality and whether they were maintaining the standards set by the guild. And yeah, there was also provided like a barrier of entry, so you cannot officially master a trade until you got the kind of masterpiece that was certified by your guild master. This worked fine for a lot of the time. Unfortunately, there was some kind of downsides. So, for example, there was no real free market and no real eye on quality. Guilds frequently kind of cheated. There was collusion, price gouging, and one of the examples I was reading while researching this was it was actually common for sawdust and lime to be mixed into flour for making bread. Not healthy. In parallel to this, in rural areas, you had kind of cottage industry. So these were groups of kind of families, family-based units, who worked to create certain class of products. And as you can guess, it was kind of haphazard, so there was no defined standards. Quality could vary between and from the same vendor. And yeah, it was basically pretty much a free-for-all, really. With the coming of the Industrial Revolution, things began to change, and this is probably where the modern ideology of quality assurance came into being. So what happened during the Industrial Revolution was that you started to get large groups of people who were performing specialized tasks, and they were monitored under the supervision of a foreman who was appointed to control the quality of the output. And as the Industrial Revolution proceeded and the division of labor kind of grew kind of more prominent, you started getting a demand for dedicated testers and quality personnel. So let's jump to the 20th century. So World War I, so you have industrial warfare, and this requires large, well-equipped armies, navies and air forces, so think tanks, armored warships, artillery, and aircraft. And this required complex manufacturing, mass production, interchangeable parts, and also a large number of workers to supervise. And during this time, observers started to discover that there was a lot of poor quality as people tried to rush products. And in particular, there was an individual called Frederick Winslow Taylor and Henry Ford. I'm guessing you know the latter. But Frederick Taylor was kind of he initiated this whole scientific management movement, and they realized that there were kind of a lot of areas that could be improved. And Taylor suggested that production be kind of divided or separated into separate tasks, and Ford basically really took this on and capitalized on this. So this is Taylor, that's Ford, and this is Ransom Old. So he actually invented the assembly line, but these two individuals really kind of capitalized on it. So Ford, through his by being influenced by Taylor, he emphasized standardization of design and components to ensure a standard product was produced, while quality was the responsibility of machine inspectors. And these machine inspectors were placed in each department to cover all operations. And they were doing their jobs or doing their inspections at frequent intervals so that no faulty operation should proceed for any great length of time. So beginning, let's jump to the 1940s and onwards. So you started getting the computing software and digital revolution. So there was a steady growth in computing devices and information systems from the 1940s. This is initially prevalent in academia, big business, military, and aerospace. Around the 1960s, you started getting mini computers. So these were computers that were smaller and much cheaper than mainframes. So mainframes at this time usually cost around up to $1 million. But mini computers really brought the price down, so it was common to find mini computers for $100,000. And the most famous mini computer of that era, the DEC PDP-8, cost only $18,000. So with this expansion of computing technology, you started also getting a burgeoning software industry. And this began to cause issues. So around the 1960s, there was something called the software crisis. And just to quote, let me pronounce this right, Dijkstra, sorry, I think that's the way you spell it. So he's a very kind of important pioneer in computer science. So he mentioned the major cause of the software crisis is that the machines have become several orders of magnitude more powerful. To put it quite bluntly, as long as there were no machines, programming was no problem at all. When we had a few weak computers, programming became a mild problem. And now we have gigantic computers, programming has become an equally gigantic problem. And here's some cartoons and newspaper clips from the era. I don't know if you can make that out. This aircraft, this was actually probably the first kind of major aerospace, I guess, disaster you could call it, from the era. I think it's the Marina 2. So actually kind of due to a software bug. It went off course and had to be kind of destroyed by the operators. So what to do about this software crisis? So the term software engineering was actually coined to deal with this problem of quality. So a NATO study group recommended that a conference be held to discuss these new problems of software. The report from the ensuing 1968 conference, which was sponsored by the NATO Science Committee, took place in Germany, and it was titled Software Engineering. Brian Randall and Peter Noll, who studied this and the proceedings, they mentioned that the phrase software engineering was deliberately chosen as being provocative in implying the need for software manufacture to be based on the types of theoretical foundations and practical disciplines that were traditional in the established branches of engineering. And quality assurance in a software engineering context was also first mentioned at this proceeding or this conference. And yeah, basically there was a report of the conference which included a paper which included checklists for planning software system production by Robert W. Bemer. And so when was the first bug in an engineering context? When did it come up? So I found this quote by Thomas Edison, who mentioned basically having kind of periods of inspiration and then having setbacks, which he called bugs. And it's remarkably similar to how we kind of describe software bugs today. So he mentioned them, or described them as little faults and difficulties that show themselves and require months of intense watching. The first software bug in a kind of software engineering context was probably kind of discovered or epitomized by Grace Hopper. So she's another kind of key figure in 20th century computer science, and reading an account here. In 1946, when Hopper was released from active duty, she joined the Harvard facility at the Computation Laboratory, where she continued her work on the Mark II and Mark III. Operators traced an error in the Mark II to a moth trapped in a relay, coining the term bug. This bug was carefully removed and taped to the logbook, stemming from the first bug. Today we call errors or glitches in a program bug. And I'm proud to show you the first bug report. So, yep, and the cause of the problem is literally taped to this piece of paper. Cool. So just moving on to how kind of software testing has evolved over the 20th century. So Dave Galperin and William C. Hetzels, these two individuals are quite important in the history of software testing. So they describe different eras of testing in a work in 1988. So the first one is, let's go back. The first one, until 1956, it was kind of debugging oriented. So this was when testing was associated with debugging. There was no clear kind of difference between the two. And this was quite kind of influenced by the academic work going on at the time. So the next phase was more kind of demonstration oriented. So this was when debugging and testing began to be conceptually distinguished. Testing must ensure software requirements satisfies the requirements. Late 70s, early 80s was a kind of a destruction oriented. So the goal was to find as many errors as possible prior to shipping the product. And finally, I guess the era we're in now, which is prevention-oriented. Tests were to demonstrate that the software satisfies its specifications to detect faults and to prevent faults. So it's pretty much like a summation of what was going on before. In 2003, Brett Pettishaw, another kind of software testing professional, decided to kind of, elaborated on this further. So he came up with testing schools, which kind of mirror the eras I mentioned. So firstly is the analytical school. So this is, again, has its origin in academia. It sees testing as rigorous, technical, and mathematical. And yeah, it basically envisions answers to kind of problems as singular, so there's only one right answer. Many proponents in academia. And yeah, software testing in this kind of in this view became a fundamental part of computer science and mathematics. So related concepts are correctness and formal verification, and basically things that we have from that era or this kind of school of thought are unit tests, code coverage, and kind of white box testing. And this was kind of very common in academia, and also actually high reliability industries, so things like aerospace, telecoms, medical, where you couldn't kind of risk things going wrong, so you need to be able to know with certainty what each line of code was doing, and this kind of mathematical certainty was the goal of this school. But as many of you know, this kind of certainty is kind of pretty much impossible with large, complex software. So this kind of gave way to a more kind of factory or a standard school. So testing here was almost dumbed down to a certain extent. It was predictable, repeatable, and planned, and it was under the direction of managers. And yeah, this kind of involved a lot of kind of battery of manual testers and following scripts. And it kind of placed a high importance on industry testing standards, best practices, and certification. And the goal of testing was to be a measure of development progress. And what we have from that kind of what it produced really is, the best example is a traceability matrix. Sorry. So next up is the kind of quality assurance school. So this was kind of very common and popular in the 1980s. This viewed testing as a discipline that requires discipline. Testing determines whether the process is being followed, and testers had a kind of additional power compared to before, so they could police developers and guide the software development process. And testers were seen as almost stand-ins for users and product owners. And probably what we have from this era is the QA gatekeeper. So this is kind of the idea of, you can't ship a product until the QA gives the thumbs up. And finally, we have the kind of context-driven school. So this is kind of very aligned with the agile way of thinking. So this sees, firstly, it sees software as products created by and for people. So testing criteria should be flexible and dynamically determined given the needs of the product. So it's reliant mainly on the expertise and experience of the tester. And one of the best examples of this is exploratory testing. So parallel to this, there's another kind of axis, which is this from a manual to automated testing. So test automation has steadily increased in importance. There was originally a big push in the 1990s due to the explosion of commercial software. So names such as SQA, Mercury, and SEG. And the goal during that period was to really remove as much manual testing as possible. That wasn't really possible, so going on to the early 2000s, Selenium came about, and that was almost a revolution in the field. And there's also, in terms of economics, the time of developers and testers was getting a lot more expensive compared to computing time. There were issues with scalability, also cloud computing, also further increased this basically price, the developer-tester over computer time ratio. And you had kind of the modern agile and combined engineering concepts gaining ground. So what has automation done to the industry? So testers these days are increasingly expected to have strong programming skills. Testers are often developers in their own right. So at QB, all our QAs are very kind of code proficient, and they're expected to be able to write code and also analyze code. Conversely, developers are also expected to be at least competent or aware of how testing is done. So the idea of throwing a product over the fence to the testing or QA department, this is rapidly getting outmoded. And yeah, so in the industry there was this dissolution of separate development and QA departments. So places like Microsoft and Yahoo, they almost disbanded their QA departments overnight. And instead what they did was they kind of placed QA personnel within development teams. So QA personnel really became developers, like traditional software engineers. Other factors include rapid delivery and development of startup culture. And there was also this idea of shift left and shift right testing. So shift left is basically bringing QA personnel on board and contributing to the software development lifecycle earlier, and shift right is continuing testing after production. So there's the idea of continuous testing. There was an increasing reliance on CI/CD and DevOps, which I'll speak on next. So DevOps. So this is a new movement beginning in the late 2000s. So DevOps, if some of you are not aware, is a combination of software development and IT operations. And the aim here is to basically reduce the software development lifecycle as much as possible. So the challenges, it has presented challenges to kind of traditional testers and QA departments. So I'm going to two questions that keep on coming up is, where does testing fit in this kind of environment, and is traditional QA dead? Which I'm glad to report it isn't. It has had to evolve to fit into this new environment. So there's a new kind of idea of a QA ops. So this is the evolution of QA into this CI/CD culture presented by DevOps. And again, this emphasizes testers being highly technically proficient and able to code. And they're also given responsibility of designing, maintaining, and extending the CI/CD architecture. And QAs at QB are, this is a large part of our daily duties. So going on to QA in data science, machine learning, big data. So this presents unique problems as well. So unlike traditional software, ML models change over time. So the focus here is on data quality, feature choice, and also the choice of algorithms. You need to have a very close collaboration with data science engineers and also machine learning engineers due to the complexity of the algorithms that are being implemented. And you need to, things like mocking data are very important. So things like randomizing data and obfuscating data become critical. You also have kind of front-end testing. This is more kind of traditional. So it's common in the field to have kind of notebooks and also matplotlib graphs, and also web GUIs to control these softwares. Things like code reviews are also very, very important. There's also the added dimension of security, confidentiality, and things like performance, and become much more important to the tester. So, future of QA. So I'm sure many of you have seen a slide like this before. So the biggest challenges are, how will QA kind of adapt and grow in this climate of big data, data science, agile, and CI/CD. And there's also, I think, a social and ethical angle here. So as many of you probably been following in the news, there's been a lot of scandals regarding data misuse. And yeah, I think the responsibility of QA in the 21st century is really to also push back on unethical practices. And I think this is, so things like professional standards and ethics need to be also kind of considered. And yeah, that's my talk. Thank you.